Hello, everybody. So we're up to module 8, week 8, last week of the class. These classes go quick, and as y'all have noticed, it's hard for us to find that too much in time to even look at the tools, and we can't even really make it dent in looking at the tools. Did anybody watch that video I sent out of all the nodes you can know?
I started
like a 42-minute video. It takes 40 minutes. Yeah, it goes quick. Like he's talking as quick as he can, and it takes 42 minutes to go through all of them. We can't, all we can do is build a foundation. So hopefully this class has helped you build a little bit of foundation. Reason I chose tutorials for all the homework is because that's most of our big game engines and also most of our small game engines have large communities supporting them and build tutorials. So lots and lots of tutorials out there to find. That's how we usually learn about the game engine. And just as you get further along, you'll move from following every step in the tutorial to just going to a tutorial to look for the one line of code you need and then modifying what to see. There'll be smaller and smaller sections of them that you need, but it's still pretty standard to go there and look at them. So that's why we did that. Looking at tools here. Hopefully it's getting a starting foundation. One of the biggest things about game engines, especially the big ones, is just to not be overwhelmed when you open them. Right? There's a lot of buttons there and stuff all over the place, and we've seen that there's actually more that are. A lot of the buttons and menus are hidden. We've been doing that a couple times with the shaders in Godot. Kept adding more and more and more stuff into that inspector panel that was already loaded down with functionality. Or we didn't add it. We didn't add to it. We just we made it visible. So there's a lot of that. One important one I want to look at input. So we have that character we started in that world where we were looking at like multi-mesh instances and generating trees and landscape. It is to use some of those tools these days. And we use the default movement for the character, which probably isn't the best one. It's on the arrow keys. And I don't know, at least to me, it feels strange moving the character with the arrow keys. Oh, yeah. There's a Nintendo emulator I know, like original NES system, an emulator website that I go to on Sundays when nobody comes to the office hours. Sometimes I go in there for a few minutes and play the games I played when I was a little kid, many decades ago, probably before most of y'all were born. But when you first go to that website, the keys are always set for the arrows, and then it uses A and S for the two buttons from the old Nintendo, and it feels weird with the arrows. So first thing I do is always reset it to WASD. So the keyboard input and mouse input, and I was thinking that moving our character around would be a good way to quickly look at both of those, see that tool, so you can start getting practice with it. I was going to do the yaw, pitch, and roll movement. Actually, not all three of them, but the movement where there's forward and backwards. And I was thinking with the keyboard, W and S move forward and backwards, and A and D actually turn the body. And then with the mouse, we'll use the mouse to do the look thing. So like move the mouse up and down to move the camera, have the camera simulating the player's head going up and down, looking that direction, and moving the mouse left and right to look, but not actually trying. Like the viewport will be the same, right? If we hit the A key, we'll turn our body that way. If we move, but then when we move forward, there's a different forward. With the mouse, when we just turn the camera that way, but the forward is still the forward we had. Hopefully that makes sense. It's fairly common, but as I was thinking about that, it seemed like the last few games were fresh on my mind, like mixed and matched it. Like the keyboard did some movement and the mouse did some movement and keyboard did some of the panning the camera and the mouse did other panning the camera. So it was like mixed and matched. But I figured we could just separate it for today's things. So we'll look at that. Really. And then raycast and physics layers. Definitely want to see those. That'll probably take a good bit of our time, and then after that, we will look at as much as we can fit in. But like I mentioned a moment ago, if y'all watch that video that I sent out that covered every node in Godot, that guy talks pretty quick and just does a very quick summary on each one, like 30 to 45 seconds on each one at the most, and it's a 42-minute video. There's a lot of nodes that we can use in Godot. Couple reminders, this is last week of class, so getting very close to the holiday break. And time to relax, usually a stressful week in class, trying to get everything done, turned in, completed, all of that, and lots of classes. Please keep in mind the final due date is Sunday, 11:59 p.m. Get everything to me by Sunday, 11:59 p.m. I never accept any work after that that time that this course was scheduled to end years ago. Like that was the one that was put on the schedule years ago, long before you all registered for the class and everything. Like these courses are going to end December 17th at 11:59 p.m. So I never go beyond that date. Last weekend of the class, I always make sure my schedule is open. So I will just be sitting around waiting for questions to come my way. Anybody try to reach out to me over the weekend? I'm not sure. I realized this morning my phone service was down. It was a very peaceful weekend. I didn't hear from anybody. And then this morning I realized I didn't have service on my phone. It's like, yeah, wonder if nobody called me or if I just didn't know they were trying to reach out to me. But last weekend of the semester, I always try to keep my schedule pretty much open so that if you have any questions as you finish up work, we can hop on a Zoom call and address those. I do teach more than just this class. My highest degrees are all in pure mathematics. So I help with math and writing. I help with lots of other subjects too in the tutoring center. So I'll be available if you have questions. Please remember to register for spring sooner rather than later if you haven't done so yet. This year, I was asked to cancel classes earlier. A lot of times we cancel classes for low enrollment the week before. But I was asked to have all classes canceled by January 3rd, which is 2 weeks before the semester starts. So if any classes here at Sellersburg that have low enrollment, which actually already canceled one, had 0 for a couple days, and then somebody registered like the day I went to cancel it. One person from Indianapolis, so he wasn't going to drive to Sellersburg campus to take the class. So I've already canceled one, and I was asked to cancel any classes for low enrollment by January 3rd. So if you were going to try to wait till the last week, go in the week before the semester and talk to academic advisors, classes might be canceled for low enrollment by then. So please register sooner rather than later. Yeah, that was the announcements I had jotted down. So does anybody have any questions before we jump into our example? Okay, I assume the silence means no questions. That's probably enough time for people on the Zoom call to reach the mute button. So we'll go ahead and jump back in here and I guess pick up where we left off the other day. We'll start up Godot. Oh, I did encounter an interesting problem over the weekend helping somebody from this class. It was a weird issue with some of his files not loading in. And Godot was saying the files were null, and all the code looked good and stuff. And after a few minutes, we realized that OneDrive was it hit the max on OneDrive. So if you have your Windows system set up where like they're on the home screen, the desktop, That's the one that gets a lot of people. The desktop and documents and pictures anymore by default will try to go to your OneDrive, not your local machine. And apparently there's a 5 GB limit. If you have, once you hit 5 gig on OneDrive, they want you to pay for it. Like, that's kind of lousy. That was the error message causing problems. So we went over that. I did make a video a couple weeks ago. It's on my YouTube channel. I think that's an announcement out in the class about it. Okay, so announcement from a couple weeks ago. I made a YouTube video about how to switch to your local machine. It's in the registry. You have to go change the registry, and that's task-oriented programming. That's the really boring stuff that's usually automated because it doesn't require any thought. But location and objective, those two things. So lots of a file address and what you're going to do at that file path. Usually that sort of programming is automated. It's really boring, but you'll need to go into the registry and switch it to your local machine instead of OneDrive. And I made a video on how to do that. It's like 5 minutes long, and I stretched it out. I think I might have went through it twice in 5 minutes, but apparently OneDrive has a 5 gig limit. So if you're doing game development, we could definitely hit 5 gig on some good models pretty quickly. So you might want to check that video to switch back to your local documents and desktop. Switch your file explorer back to local documents and desktop. So we want a project here, so I'll go ahead and open that. Oh, before I open that, let me get these thumbnails out of the way. You may have noticed there's not an open button. I should probably, that's an important one in Godot. Some other game engines are very similar. Let me go grab something off Drive real quick. Over to Drive. Yeah, this is why I don't switch off OneDrive, because OneDrive only works on the Windows machines, and I have Windows, Linux, Mac, Chromebook. I teach, so I try to use the same computer when somebody comes and asks questions, which OneDrive becomes very problematic there for everything. So I have some games in here. So this one. So this triathlon game's a Godot game, so I'm going to copy that, just paste it into the documents folder. Maybe I could have copied over a smaller one. Okay, I did not realize how big that one was. I wasn't thinking very clearly of that. I should have realized that. It's a 3D triathlon. You run around the track, jumping over hurdles, and then row around a lake, and then get on a bike on this really hilly thing, and like ramp and grab a bunch of flags. Sometimes flags are in the air and stuff. So there's a lot going on in that game. I didn't think about size. I probably had some smaller ones. Hopefully it won't take too long here.
You downloading a demo?
Yeah, this is just a game that I had, but I was going to point out how to open projects. And I didn't realize it was going to take so long. Oh, it shouldn't take too long. Other game engines do the same thing, because what I wanted to look at is there's no open button. Right? Most, like our Office software, if we go to, say, Microsoft Office, is there a mouse pad? This phone's not working. If we go to like Microsoft Office, or actually most software, there's a button that says open. We have another file or project, we just click the open button. But you'll notice we don't have an open button here. So I wanted to show how to do that. And how long is it now? So halfway, and it's probably gone to little bitty files. So all right, now it should pick up speed. when you have a big project, sometimes copying them gets like that too. There's lots of little files, all those little independent things barely have anything in them, have to transfer one at a time. So you don't get even transfer speeds. I assume everybody has base knowledge of that. Even if you haven't had a networking class, you know about transferring and stuff. And you'll see the like speed that I always talk about networks and top speeds, but we pretty much never reach top speeds anyway. But it's also not all files transfer the same. There's like this section right in here, we see on this graph, several hundred files that only have maybe one line of code in each one, 22 lines of code in each one, or just a few dozen numbers. And they're little bitty files, but we have to transfer those files one at a time before we get to the next one. And those off our speed. Because that's why we're getting into sockets. I guess I can talk about that. This is game development. So using a normal connection, like a website connection that's designed to transfer one chunk of data. There's several files there, and it might be rather large, but your website comes in one chunk of data. Video games do not do that because there's live interaction back and forth. So we often use what's called web sockets. Really easy to put together, but the computer and the server form a unique connection with each other. So they each have their own independent tunnel. You'll see that in some of your other classes further on down the way. But so now here's a Godot game, but if I want to open that, what we do is have to hit the scan button, and then we scan the parent folder. So like here, if I go to my user account and then the documents folder, here's where that project is at. So I want to scan the parent folder to look for any Godot projects in there. What's the warning? And yeah, it was edited in 4.0. That is as long as with Godot for years, all the way going back to the first Godot, going back to 1.0. As long as the first number matches, you're okay. With Unity and Unreal, that is not the case. Right, we have the version update patch numbers. With Unity and Unreal, it needs to match all the way down to the patch. All three numbers have to match. So if you made it in, say, Unity 19.2.7 and tried to open it in Unity 19.2.8, there could be problems. Same thing with Unreal. So usually when you're making a game, do not switch versions of your game. Never update your game engine until all your projects, if you have any open projects. If you want the updated version, maybe install both of them, and then that way, and then work on new projects on the new updated version. But never update your game engine mid-project. I just wanted to show that button how we open files if we need it. We don't necessarily need to look at that one because we've got our own thing to do. Yeah, it wasn't super nice. That was the one that was the game I used to learn Godot for. So there's a triathlon and stuff, but I was learning all the changes between Godot 3 and Godot 4 with it, so it's not very cleanly put together. It's certainly not optimized, but it's playable. Okay, so here's where we were the other day. Did our water shader. Play around with those, and you'll definitely want to spend some time with shaders. So shaders are programming the materials. We could do everything that's in a material, right? We saw down here, recapping where we were last week, right? All those properties of what sets up a material, the albedo of it, how transparency, metallic, roughness, specular intensity. Specular is like how reflective is it, and how bright is the reflection. Y'all have probably experienced that in parking lots before. You're walking through a parking lot, and two freshly washed and waxed cars are next to each other, reflecting sunlight, and maybe one of them is, so that's specular. They both reflect a lot of light, but maybe one of them is blue and the other one's bright, the other one's silver. There's a different intensity to that light that they reflect, right? The blue one you can probably look at, and the silver one on a bright day in July or something, you might have to turn your head away or put your sunglasses on because there's just more intensity to the reflected light. We have all that stuff, so we could just do material, but usually with shaders, we're thinking about our time. We want to add time in and things like that water there or that sky we did before that, where the material adjusts with time. And you also want to go in there and play around with the numbers from our example. We were short on time and see what it can do. Click on different boxes. When you have more time, like over the break, there'll be a lot more time to just click around and do stuff after the class ends here. Otherwise, we have put our world together. And just recap on where we were last week. So we used the generate landscape button in Blender and generate tree button in Blender. We just made 2 trees and then used a multi-mesh instance to make lots of copies of that tree, which is very efficient for processing. It won't bog the computer down if you do it that way. If you tried to bring in this many trees, this many unique trees would start to, that's a lot for the computer to process, especially for a background thing. We want our processing power for foreground. Then we did a couple shaders, and at some point in here, we made a quick player, just a capsule, and did first person view. It seemed to work that day. And what we're getting ready to do would work equivalent for third person. The only difference between first and third person here is where the camera sits. Also, with third person, we'd probably want the scroll wheel to go in and out. After we see their inputs today, the scroll wheel is almost identical. The scroll wheel is just another mouse movement. We'll see that it'll be almost identical to what we do with the other mouse movements and buttons, or at least with the keyboard buttons. We might do both of them. I'll do mouse buttons the other way. It'll be almost scroll wheel will be almost identical to what we do with mouse buttons, or sorry, keyboard buttons. And then we'll do mouse buttons a different way. So there's multiple ways to do it. The third person, we probably want that camera to scroll in and out and change how it is at different angles. Like usually if we're way out and above, or if we're looking down on it, it's scrolled way out. But when we're closer to straight on, something like that, we're zoomed way in. So that different size thing, differently, it follows suit from what we're going to see. We put that character in there. Yeah, I guess that's most of what we've done so far, isn't it? On the current scene, take a look at it. But all we did for our character was use the default script that Godot gives us for a character. So, for one, we're moving with arrows, which I don't know, that feels strange to me. Like a lot of keyboards don't even put much emphasis on the arrows. This one I have here, the up and down arrows are really small to make them fit. Yeah. Some keyboards up and down are okay size, but the left and right are small to make them fit. So they tried to squeeze them. Sometimes all 4 arrows are really small compared to the other keys. So we probably want to switch to WASD movements. Oh yeah, we also created that treasure chest with the shape key because we haven't seen that animation yet. But we move around, walk around this world, do stuff. Can't really turn. We can't look another direction yet, so we should probably address some of that. Yeah, I'm going to do that in the script. So I'm going to do the mouse one first, where we'll look in different directions with our mouse. I have an example to refer to and did not bother to pull it up. So I'm gonna go over to the player and open up the player script. So the zoom buttons get out of the way. Okay, boom, I can go to the bottom. So here's our player script. I should grab one of my other computers so I can open up the example I was going to refer to, just in case. Oh wait, not the Mac. Happened recently. I went to sign in to GitHub on my Mac, and it wanted to send me a code, and I was like, I don't have time for this. I have several other laptops already signed into GitHub. Oh, this was not even booted up. Maybe I should have used the Mac and just waited for the text message. So there's a couple of different ways to do this. We saw in our quick preview how we can label buttons and stuff. We'll do that for the WASD keys. I wanted to look at another one that we haven't really touched on here, and that is unhandled input. Which is something unique, right? Because the mouse, we might need the mouse to do other stuff from time to time. If the person playing our game happens to be streaming it on Twitch or something, they've got all kinds of other stuff they need their mouse for simultaneously with our game, right? So they need to be able to use the mouse for other stuff and the game both. Or sometimes the keyboard might be needed for other stuff. I guess Twitch would be another good example of that. The keyboard, we're going to use some of the keys for our game. We're also going to use that same keyboard for the chat room. So we need more than one functionality for them. So these named things, that's our handled input. So we want to look at unhandled input. So I'm going to do the mouse that way. As soon as I pull up my script, I think this is it. Yep, that's the one I wanted to look at. And this fits in that pattern. We have the other process. So we have ready function, which I'll just put pass for now. Pass is just that syntax requirement that something has to be indented whenever we declare a function. So pass is the instruction to not do anything. It means don't do anything, but the syntax requires us to put something there. That's often necessary. So ready, we'll run one time to initialize things. And then in most of our game engines, we have a couple options on how we handle each frame. Godot went with the model of we can either have graphics priority. So if we do underscore process, that's the graphics priority of every frame of the game. Or we can do physics priority. We can give physics more priority than graphics, which on small games isn't going to make any difference. And but whenever games get very, very large, what is more important? That your character graphics glitch out a little bit or physics glitch out a little bit. Right? That's going to be different every single game. Sometimes you need those physics to be running absolutely precise because the gamer is going to be going off their instincts and what they know about physics. So we want to make sure that's absolutely accurate. And we can handle a little glitch like the player's arm goes through a wall because we need that processing power to keep our physics accurate. Other games, the complete total realism would be more accurate. So Godot kind of set it up that way. Which one would have priority? There's different ones. Unity gives us a time-based thing. You're getting into Unreal right now. We have control over which way we do it in Unreal. We choose how we do it in Unreal. So it gets a little more complicated. The other engines that were built, those other two is built in. So Godot, you get choose physics or graphics priority, and in Unity you would choose the beginning or the end of the frame. Somewhere in the frame, let the game engine choose when to do it, or you can specifically say do this at the beginning of the frame or at the end of the frame. Unity also has an absolute time thing. Absolute time is problematic. Early games tried to do that, and it became very problematic very quick. So I'll go back a few years, 60 frames per second. Like when our games were over in 60 frames per second, just because that went on for long enough that I have that number memorized. So 16.7 milliseconds. So we can run a lot of code in 16.7 milliseconds. But our games can get very, very big. Can we fit all of our code in 16.7 milliseconds? And there's problems both ways. Most of our code, most of our frames probably do not need 16 milliseconds, which means for most of that frame, nothing's happening. We finish the process and say 4 milliseconds, and then we sit still for 12 milliseconds. All of that sitting still is going to, there's more of that than there's more of that. So that's when games start to look jumpy, because there's a lot of just idleness, and eventually the human is going to perceive that there's more idleness in every frame of the game than movement. And the other one's even worse. If it just so happens that we can't fit all of our code in that allotted time, then it's going to move on to the next frame without running all the code. And that's a big problem. That's going to cause the game to crash. Probably immediately, but sometimes it might just create a problem that escalates into something later. But both of those are really, really bad. So what game engines do is they do their best to try and average the time we set it for. So I believe it's 140 frames per second by default. So it takes the last few frames, does that time scale and tries to average, and then for the current frame, it tries to average that in with the last few frames to make sure we're getting as close as possible to that value. Y'all probably play games where you see the frame counter on there, right? It changes, and it's important for it to change and be dynamic, because hard coding the time for a frame was a problem. But we'll usually do that. And we see our handled input is right here, the stuff we're already handling. But along with those, we'll also often need to work with unhandled input, which is going to be a unique function. You see right there in the predicted. Unhandled input, unhandled key input. We'll just do unhandled input, and it takes in some event. An event is just something that can happen. The microphone picks something up. Eye tracker notices an eye moving. The thought wave patterns, people are starting to try to get those in a little bit more. It's actually a really cheap way to do that. So some engineers in China made mouse ears, and they had a bunch of ideas, thought it was cool, but it was like on a headband thing, some little mouse ears that would move depending on how the person was thinking. And the engineers in China, on this particular one that cost about $12, went ahead and just added another 7 or 8 connections to that circuit board, thinking that more people were going to buy the mouse ears, rip them apart, and hook more things up to that thing that can pick up brain sensors, which a lot of people do. So those things are coming more and more. So maybe that happened. Obviously, key presses, moving the mouse. That's the event we're worried about. Timers, something that can happen. The computer detected something. That's what an event is. So obviously we need to check what it is. So I want to go with the mouse. So if event is input event, which one? Mouse button. I'm going to do it this way. So this is just an overall catch so that we can do something else with our mouse. So I'm going to say the if else here is going to be like a mouse click or the escape key. I'm going to write it as an elif because I don't want to, I can't put one else. That would encompass every single event. But just the binary states, a mouse click, and then then we will start listening for mouse events in our game. If we hit escape, then we won't listen for mouse events, and the mouse can be used for something else. Just a useful little thing. So when we click, then we'll do input dot set mouse, which did not show up on the predictive text for some reason. I don't know why, but it works. Things that we type in there shows up in the predictive text, but there are certain things in this engine that just don't show up in predictive text. I'm not sure why. Probably the open source aspect. And now, what do we want to do? Let's say input mode capture. So if the mouse button gets clicked somewhere in the game window, then we're going to start listening for mouse events. Otherwise, the mouse is free to work with other software, right? So, yeah, it's not going to crash at this point. In this real quick. It's small, but if I move this over to the side here, so it's on mine. If we click over in this area, the game's going to start listening for mouse events. But if we click over here, the mouse is going to do stuff on Godot. So I like to add in a little block like that. It's optional. We could just do this for every mouse mode, set mouse mode to capture it all the time. Some people do that, but I like to not do that for the reasons I already stated. You might need the mouse for something else. Otherwise, and I'm going to do elif because there's a lot of other events that could happen. I only care about the two. We need a way to get out of it. Right? If we're using the mouse in the game, but then suddenly want to go over there and, well, for game development, we want to go over and click on the inspector panel and change some values while we're debugging. Might be a good example. We need to get our mouse back. So escape key is a good way to do that. Right, that event that is passed in, and then we can just use one we've already seen, is action pressed. For the escape key is UI cancel. Everybody remember when we were going through the preview mode that we can change that? Okay. My initial plan was to do the keyboard first, so we would have just changed it a few minutes ago. We can rename that maybe when we get over to the board or get over to our handled inputs. We'll change the name of that, do something else. But for now, UI cancel is the default name for the escape key. And in this case, we'll say input.set mouse mode in snake case again, so those underscores. Godot was really consistent about the naming conventions. Actually, Godot, Unity, and Unreal were very, very consistent in the naming conventions. They all use different ones, but all three of them are very, very consistent.
You typed in made.
That's that.
You typed in set mouse made.
Oh, thank you. It would have been a minute before I noticed that. Dangers of talking and typing at the same time. So set mouse mode and input mouse mode visible is the one we want here. Input dot mouse mode visible is visible for other software on your machine. So once we're listening, and this happens, this is an interruption. So this is not the frame of the game. Right? I'll go back to the 60 frames per second, right? We have 16.7 milliseconds. But user input should always get priority. So this is for handling our are interrupt events. Escape key is a great example of it. That's how we get out of stuff when it's not working right. Right? Everybody seen that? Done that a few times? Things are messing up. First thing you try is hitting the escape key, see if they get you out of there. That interrupts whatever the software is doing. Human priority over CPU. So just stop what's processing and give the human priority. That's our unhandled input. And the name is very, very similar in all our big game engines. So it might be written in Pascal case, just capital first letters and words jammed together. Snake case like Godot, might be written in camel case. So you'll see it written different ways, but the name's very, very similar. Something to handle all our interrupt input. And then we can use that to adjust our camera. So like if the event is, and this is trail over from Python, that's the same as equality, but it's just kind of nice to have the word is. It seems to make sense with it fits nicely with our rest of our code. But if you prefer to type the equal sign there, equal is equivalent to is. Input event mouse motion as one big word. Mouse. Oh, you can see there. So input event from the mouse, and then we can sort it out later in our code, or input event from a mouse button, or input event from a mouse motion. Let's do a motion. Because a mouse button, notice we just said mouse button, we didn't say which button. So any click in our right click, left click. Let's check the scroll wheel. I don't think scrolling will work, but clicking the scroll wheel will work.
What about extra mouse buttons?
Extra mouse buttons will work. Yeah, so the thumb mouse buttons are however many you have. We just said if there's a mouse button, then we go into capture. Our game gets to capture mouse events. But if we hit the escape button, mouse events are visible to other software, visible to the rest of the operating system. The operating system decides who gets the mouse button. And here we just need to move our camera. Excuse me. So I'm going to type pass for a second, and then we'll come back and look at the different what we can do with it. If I come over here, there's our camera, and that one we keep coming back to. Our other big game engines always put transform at the top. I really like that about Unity and Unreal that Godot didn't do for some reason. Is in most of our game engines, transforms at the very top of the list because that's the one we always come back to over and over. And hopefully by this point in this course, you see why that's the one we keep coming back to. So we move the camera, rotate the camera, or scale the camera. Hopefully it's very obvious which one we want to do there. So let's check views. So we can just watch these numbers to see what we need. So to look up, if I grab this and spin that backwards, so we rotated X, positive to look up and negative to look down. It's good to have notes somewhere. I'll write them on the board. I'll turn around and write it on the board behind me. So X positive is up, negative is down. Usually scrap paper, right? We're dealing with a lot of boxes, so sometimes to help get your thoughts in order, it's helpful to draw a box and scribble around it and think about what you're doing before you start writing code. We also need to look left and right. I guess I'll need to turn here. So obviously left and right is going to be a rotation around the y-axis. So I grab here, and that's looking left. So y looks like positive rotation in the y to look to the left. which immediately tells us what the negative one is going to do, right? So positive left, negative right. So now we're ready to add that into code. I'll go ahead and reset this so we start looking forward. Jump back over to the script. I'll leave it there for a second. Reference room to type. Yeah, because the stuff below is going to go down. I'll leave it there for a second so you can see what was there when you stepped out for a moment, Samantha. So if it's a mouse motion, we just need to determine which motion it was. So I'm going to make a couple variables. So I'm going to do horizontal and vertical. So our horizontal look is the event. Because at this point, we know the event is mouse motion. So anything that we have in our mouse, we should be able to access from the label event there. So event, and that does happen to have a few things relative. So what was the relative movement? Not the absolute movement. Absolute movement gets a little bit tricky to work with. What was the most recent relative movement of the mouse, right? It was like right now, you can't see it, but my mouse is kind of angled like that. So in a few moments from now, the mouse might be angled that way. Or I could turn sideways in my seat and turn it completely sideways. So absolute motion gets a little bit complicated. So relative is what was the motion relative to its last position? Which way were we most recently moving? And obviously, the mouse only has the two dimensions. So we have an X and a Y. So our horizontal looking is going to be the X movement. And there's going to be a lot, but we'll come back and fix there. It's like, kind of like that delta thing again. Right? A little bitty mouse movement is going to translate to a lot here, but we'll multiply by a smaller number when we see how far off it is. And then we can do a vertical one. So vertical, again, event, the relative movement, and we just want the Y component of that movement. And then we can rotate our camera respectively. So we need a reference to the camera because our script is on the character. Probably should have called that player up here, but it's fine. So to get a reference to the camera, I didn't rename it here. Still kept the original node of the name of the node. Y'all may have noticed in the 2D tutorial, he kept using the string of that. So it's a really good idea to rename those into something meaningful, especially if you're going to have a bunch of them, like what we have over in the world. If you have a bunch of things, it's a good idea to rename those, and then you use that get node and pass in the string of what you called it in the hierarchy. So we can do that, but a better way to do it is to ask for it in our ready function, because this runs when we initialize everything. But with Godot 4, they gave us a shortcut on putting things in the ready function. If you click on it and then hit Control and drag it over, I'll put it down here. Whoops. Drag it to the wrong spot. So click, Control, drag.
Isn't that the ready function where you?
Yes. So this is a shortcut. So they gave us this annotation shortcut. So instead of putting everything there, we can do all our declarations at the top, which is a little bit cleaner code wise. And then when we get to the ready function, we do process. So all we're doing here is declaring it. We have some variable, that's a long name for it. I'm just going to call that camera. We can call it eyes. Eyes seems easy to type. It's give it a useful name. That's all a variable is a useful name for whatever location in memory this is stored at. I am going to add a colon in here because that drag does the dynamically typed version and strictly typed will always be quicker. So this is the type assignment. It's like assign this value and figure out what type it is now. That way that way we don't waste time later figuring out what type of data this is. The reason Python is so slow, like games, we have a lot going on, so we don't want to waste that time, even if we're talking like a few nano to a few milliseconds at most, they'll add up in a game. A few nano to a few milliseconds, 140 times per second, is going to add up to something human notice pretty quick when we have 5,000 things doing that 140 times per second. So it's a good idea to go ahead and do strictly type. Or you could just type this. So the annotation at ready or at on ready means do this for initialization. Create a variable, we'll call it eyes. That's a sign. Color sign node 3D is how we refer to things in the hierarchy. Hopefully that made perfect sense. And then slash camera 3D is it's indented one layer of indentation from where the script is located. Script is located on the main character body. All that makes sense. Because sometimes that control drag thing works a little funky and it might be just quicker to type it. Because we know what those things are if we built the game, right? If you're following a tutorial, it's hard to remember what all they are, but if you're the one that built the game from scratch, then you know what all those things are.
Hopefully.
And now we can just take that mouse movement and translate that into our rotation. But we have to reverse it. Go back to so with the mouse, it's very straightforward. Is that on the camera? I hope that's on the camera. Yeah. Right. Up and down with the mouse is a Y. Left and right with the mouse is X. It's exactly like what your 8th grade algebra teacher taught you, right? That one the mouse never changes from. However, our character body starts with the Y-axis up, the X-axis to the right, and Z-axis pointing backwards, and we're going to do yaw, pitch, and roll movements. So we're going to turn this way. So that forward is going to change. Physics are applied. We have a character body, so the rotation is locked. We could unlock that, or maybe we used a rigid body so that it actually goes off center of gravity. And what's up might change if we start flipping, right? A boxing game, and we do a backflip, and for a moment there, the angles change. The angle of what's up is different. So in the game, up and down and stuff changes. But up is Y, and we need to translate that vertical and horizontal linear movement into rotational movement. So it's actually our X movement that we want to spin around the Y. As if I grab the handle and move, grabbing the Y handle and moving the rotation is around the Y. So it's our X axis that moves around the Y. Same thing, move around the X, we're moving up and down the Y axis. Actually, Z is involved there too, but we can ignore the Z for what we're doing. But to move around the X, it's actually the other two axes that are involved. So our Y movement from the mouse needs to translate to X movement here. Hopefully that makes sense. Everybody see how that little translate linear to rotational change. So to turn left and right and say that camera, we call it eyes, give our camera a nice useful name. Something meaningful makes it a lot easier to debug than trying to call it camera _3D and remember what it was for. Well, it has transform data, so we have a rotation. And then rotation dot y, so around the y is rotation dot y, I is dot rotation dot y, or just plus equals. We're just going to increment it and decrement it by that amount here.
Wouldn't that be vertical?
We have to change it. So our X motion becomes horizontal. Actually, these words are backwards. So I'm gonna switch this one to vert and this one to vertical and horizontal that way. Oh wait, no, that was right. Sorry. You made me question everything, start questioning everything. So this is, we're rotating around the y-axis. So like y is our vertical axis. So rotation around it like this is how we look horizontal. That makes sense, Zachary?
Yeah.
So the horizontal panning of our eyes. And then everybody okay with the shortcut? That's the same as, I'll go ahead and type the line. Just, I know some people are eyes dot rotation dot y equals eyes dot rotation dot y plus 4. Those two lines are the same. And we have that abbreviated version in pretty much every programming language. But sometimes some people like to spell it out because it's a lot easier to debug your code that way. You don't ever have to stop and think about what shortcut you used. Same thing for X. Eyes dot rotation on the x-axis. So looking up and down, X is positive. Our to the character's right is positive X. So we need to spin around that axis. So we'll just increment by verb, and we're getting the relative motion from our mouse. So that's going to be both positive and negative. Could be backwards. We'll have to see where it is when it comes in. It's also going to be really, really fast. But we'll see that in a second. So I'm going to give that a save. Go back to the world. Okay, my little thing there's not working. I'm moving upward and it's spinning really, really quick, right? I'm having trouble telling, I'm having trouble telling whether that's spinning the correct direction or not. Did y'all see that thing up in the sky?
It doesn't like, it spins really fast for me when I do it.
Yes, it is. Like I can't tell if it's spinning the right way or not. It's going so fast. And my other part's not working. Escape key is not working. I don't know why that one's not working. Oh. If input get, let me type this and hopefully it'll make sense. Get mouse mode is input mode. Capture. I didn't do that in my example. I think I need to do that. We don't want to do this every single time. We only want to do this if we're capturing mouse event. Why doesn't it like that?
Don't think it's cool.
Yeah. After the first if. There is.
Could not find type mouse mode captured. I must have spelled it wrong, but I know it's spelled correctly up here, so I'm just gonna copy and paste.
You copy and paste.
Whoops.
Too.
Eventually get these typos fixed. I know that works. Don't do the comparison. Just do this. Okay. I don't think we don't really need to do a comparison there. Let's see if that fits it. And then we'll get the speed thing. I left that out of my example apparently. No, it's still doing that. What do you think you see there? Let me check another example where I did include that. So I'm apparently copying from one that doesn't work. But while I pull that up, we can go ahead and just move this back like it was. And
Couldn't you put is it and or input mouse in motion and mouse or whatever?
Yes, that's what I was kind of doing. The nested if statements are an else. So an if statement nested if statements are an and. So anytime you want to write and, because that can get really, really long sometimes, right? If you put an if statement inside of another if statement, that's an automatic and. Because both of them have to be true in order to hit that. So it's like and with a line break. It makes your code look a little bit better. But I apparently can't remember how to type that. So the speed is kind of like the delta thing here.
Wouldn't we be looking for mouse mode visible?
Mouse.
Because that's when you're tabbed out of the game.
It started and it didn't register the first part. I have to look at another example because I think I'm forgetting something. Mouse mode visible is visible to the operating system. And mouse mode captured means the game gets all the mouse movement. But it's starting the game with mouse mode captured and it's not leaving it for some reason. Oh, but the speed thing is just kind of like this delta, the length of time and last frame, which we do not have for interrupt events. This is unhandled input is for anytime we have a keyboard interrupt. Our handled inputs are going to happen at the frame rate of the game. But this is just going to grab keyboard, make interrupts on them. So we just need a really small number. Times 0. What did I do when I was getting ready? 0.3. Let's see what that does. That's much, much bigger than whatever delta would be, but that should slow us down quite a bit here. And again, this is just a number you're going to run or try and refine. So I'll bring the mouse out to the middle. If I move to the left, that's still pretty quick, isn't it?
It's still too fast, but at least you understand what takes happen.
Yes. Actually, there's one other thing. Has anybody had a trigonometry class? Maybe free calc in high school?
Very long time.
When we look at this transform data over in the inspector, and I need to try to find a mouse pad when we take a break here in about 5 minutes. When we look over here, notice it's given it in degrees. So I went over to the code and just kind of translated it that way. But that is only adjusted for the output. It actually measures everything in radians. If you haven't had a trig class, so degrees are like spinning around a circle. we go, and there's no length involved, right? If we have different diameters, 45 degrees is going to cover a different, like 45 degrees on a tire. 45-degree turn on your little bitty lawnmower tire is a couple of inches. But a 45-degree turn on a bicycle tire is going to go probably over a foot for a full-size adult bicycle, right? There's a big difference in that degree. So if there's no distance involved in it. So another way we can measure angles is we use the length of the radius. So remember the formula for circumference? Circumference of a circle, if we're looking straight down from the top, we have a nice little circle here. Circumference is pi times diameter. The radius is a much easier number to know, usually. So we also have pi, 2 times pi times the radius gives us all the way around. So 2 times pi times the radius all the way around a circle, and it gives us a way to measure angles that includes length as well. A much better metric to use. So we need to measure our angles that way.
Out of curiosity, why does that matter exactly?
Different situations give us different things. So it really applies in the physics more than anything else, because when you get to calculus, derivatives don't work with degrees. Is probably the biggest reason for game engines. Degrees don't have any length associated with them. So when we get to calculus, which is about rates of change, and then that leads into differentials, which differential equations is the first math class where you finally see word problems that are all measurements that can be taken from the real world. I'm sure everybody knows the jokes, right? 47 watermelons and 18 apples, and just those are going 34 miles per hour, and all those ridiculous numbers they give you in word problems. Differential equations is the first math class where every single value in the problems is an actual measurement that can be taken in. And physics is based off that. So differential is change of one thing changes another. So when we're thinking about X and Y, I'll just try to generic. If we want to calculate Y, what we're really worried about is how much Y changes for a change in X. If we increase X by 3, what does that do to Y? We need to do that in order to process physics. And in order to do differentials, we have to have calculus, and degrees don't work with calculus. So that's the more technical reason for it. But just think about how degrees don't give us any information, right? 45-degree turn on your lawnmower wheel is barely anything. 45-degree wheel on a full-size bicycle, like 18-speed bicycle, racing style bicycles, probably a couple feet. 45-degree turn of the earth is 7 times 3 is 1.
Many miles.
43. So about a quarter of 42,000. 10,000. So 45-degree turn of the earth is 10,000 miles. There's no length involved in an degree angle, so we don't have we're lacking something from calculation. Basically, you just need to,
like if your character say rolls, how far they roll.
Yes.
Instead of just like for a camera, it doesn't matter if you're just turning the camera, but for something like that.
Yes. So the physics engine would handle that, because we would just make it a rigid body, so the physics applies and then push our character. But in order to do that, the physics engine needs it to be in all angles measured in radians. So anytime you're working with an angle, make sure you put in this function right here, degree to rad. And don't forget about the situations where you need to make it smaller, because you're probably thinking about how far are you turning per second. So now we have an angle going in there. Actually, I think I want to put the parentheses here. The amount of our mouse movement, we're going to make that much smaller, or a little smaller, and then we'll just say that's an angle in degrees, and we'll turn it into radians. Now it should look a little bit clearer. Also, it's time for a break, right? Oh, whoops, wrong world. So if I move left, moving my mouse left, I can see it's going the wrong way now. So those are backwards. So I think I just need to switch positive and negative. If I look up, move my mouse up, I look at the ground, move my mouse down, I'm looking up. And then, yeah, there's the problem with that shader we made. It's quick and easy. But if the character does this, you see that little flower petal spiral thing. And if you have more clouds going on up there, it kind of messes up. But how often do we do that in the game? And alternatively, you can also hide your sun right there for your sun direct.
Also, just human tendencies we don't look up.
And escape is not.
It's a scientific fact that humans.
Yeah, not very often. Because it hurts us.
Well,
we learn when we're young, if we do this too much, this is going to hurt my neck.
Well, even beyond that, it's also an evolutionary thing. Humans don't have anything above them they have to worry about. In general, we don't have anything that we have to.
Yeah, we're too big for eagles.
Yeah, we have no instinctual. We need to check to make sure nothing's going to come at us from above. So.
Oh, we're a predator. We have forward-facing eyes. Prey animals see out and up. But yes, humans are a predator. We don't need to look up unless we're hunting them.
Unless there's some above we want.
Yes.
Yeah.
So that's working. I skipped the line of code somewhere in the example I was referring to. So I'm gonna have to what that line of code was, because what I tried to do for memory didn't work. But for some reason we're not not doing everything all at once. Let me try this real quick. Maybe I just need to do this. Capture the events. Control K. I was trying Control Slash. That's normally Control Slash comments things out. If you hit Control K, it'll comment out a bunch of stuff. Let me see if this works, and we'll take a break either way. So I just moved all of that stuff up there under that mouse mode capture. Oh, there we go. So notice I'm moving my mouse, but nothing's happening. When I click, oh, stop that previous run. No, silly. I didn't copy enough. I'm going to cut and paste this time instead of copy. Oh, how did I do that? This stuff all gets in it. I forgot to copy the if portion. Wait.
Now you have if event, you have the same if.
That can't be what the problem is there. Let me try that again, reading the error message.
It looks like you deleted mouse capture.
Oh.
When you paste it.
There we go. Then I need the if check and event is input event mouse option. And then did all this. Something looked very, very strange because it was saying button and motion. Give this a run, see if this is what I'm looking for. And during the break, I need to try to find a mouse pad because I'm on a folder and it's really, really sticky. So it's not happening, but when I click, oh,
You're under the if event mouse button, I guess. Right? So
should be.
if you're not hitting a button, because above your if event mouse motion is if event mouse button.
Oh,
So
holding the button down.
yeah, you have to have the button pressed for it to then go into the rest.
Okay, that works, but that's not what I was thinking about. Oh, it's not carrying through.
Still doesn't work.
I'm gonna go back to what it was, but the escape button's working, so maybe I'll skip that capture part and we'll just this allowed us to look. And it's already 3 minutes past. 3 minutes past what I was looking for breakdown. So we can now look around.
During the break.
Oh, I forgot to change those negative signs, didn't I? Gonna close that. And I'll just put a negative here.
What about that sequence that you have there between the rotation and the degree?
That is the same. That is saying to apply the same variable on both sides.
Okay.
So now left goes left, right goes right, up goes up, down goes down, and we're able to look around. So let me quickly raise. So this is something we do. We'll change the variable x.
Yeah.
So,
That's what. Yeah, I'm aware of that. I was making sure that was what that was.
yeah, those are equivalent statements. Some people like to spell it out the whole way. If you want to spell it out the whole way, that can't really make the argument that that doesn't make it easier to debug because we don't have to stop and think. It's clear what it is. So that's a start. I'm going to see if I can remember what line of code I'm forgetting. Just make sure we're in captured mode. We can see the camera, how we described that. Well, the name there is nice. Unhandled input. Our hardware interrupts. We all go into unhandled input. After a break, we'll do handled input, and whatever line of code I'm forgetting there, I'll have to dig it out of another project because it didn't make it in the example I was looking at. Does anybody have any questions about that much so far? It's something you can start playing with, right? Because you can easily take, instead of rotating the camera, rotate your camera and use your keyboard to rotate the camera. Hopefully that's an easy transition to see. Otherwise, 10 minutes sound good to everybody?
Sounds good. I do have a question here then.
Okay. We'll get back to this at 2:30. I'll see y'all in just a moment.